So the chemical reactions of carbonyl compounds. So we will understand the chemical reactions of carbonyl compounds. What are carbonyl compounds? So basically, aldehydes and ketones are known as carbonyl compounds. So first reaction we will see is a nucleophilic substitution reaction. Nucleophilic, not substitution, addition reaction. Okay. So basically, aldehydes and ketones undergoes nucleophilic addition reaction, right? And these reactions are basically catalyzed by both acids as well as base. So we will see some important nucleophilic addition reaction. Like first, let's see, when aldehydes and ketones reacts with HCN, HCN, what will happen? We will see. So basically, when aldehydes and ketones on reaction with HCN, they will give cyanohydrins, and the reaction is very slow, so it is catalyzed by a base. Let's see how the reaction proceeds. Let's suppose, for example, CH3CHO. Let's take an aldehyde. You can take ketone also. So what will happen when this CO bond, in the CO bond, which will get positive charge and which will get negative charge when the bond is break. So obviously carbon, this will have partial positive charge and this will get partially negative charge, right? So in the presence of HCN, HCN will give you CN minus, right? So this is negatively charged. It will attack on this carbon, right? And this bond will this CH3, CO minus, here CH, and here CN group. Okay. So in the H plus, in the presence of acidic medium, you will get cyanohydrins. What is cyanohydrin? CH3, here CH, on the same carbon, here CN will be attached and OH will also attach. This is known as cyanohydrin. Okay. Okay. So next we will see the nucleophilic addition reaction in the presence of sodium hydrogen carbonate, right? So let's take CO. This is aldehyde. If you add hydrogen here, it will become aldehyde. And if there are two alkyl groups, then it is ketone. So when you take carbonyl compound and you add NaH, sodium hydrogen carbonate, right? So Na will have positive charge and this not sodium hydrogen carbon, sodium hydrogen sulfonate, SO3, right? SO3. Let's take SO3. This is SO3. Okay. So here this will achieve negative charge. So this will act as a nucleophile, right? So what will be the nucleophile here? HO, HSO3 will be the nucleophile, right? So it will act as a nucleophile and at this site, here is negative charge. This will attack on that carbon, okay? From this side, from the oxygen side, not from the hydrogen one. So you will get this bond is like this, and you will here the CO bond will break, and here SO3H will be attached, and here with oxygen, sodium will be attached, right? So here, next step will be the proton transfer, right? These protons will get exchanged, right? Proton will, here proton transfer, proton transfer, right? So what will happen? O, SO2 and Na, right? And this you will get OH here. So what is this? This is basically a bisulfide addition compound. Bisulfide addition compound, you can say. Got it? Okay, the next type of nucleophilic addition reaction is addition of alcohol. When you add alcohol to carbonyl compound, what will happen? OH, that is alcohol. So let's take example. Okay, CH3, I'm taking aldehyde. When you give ROH to aldehyde, what will happen? If this bond will break, this OH will get negative charge and this R will positive charge, right? So here also, this will get partially positive charge and this is partially negative charge. So this OH will tag this carbon center, right? And this happens in the presence of HCl, gaseous form. Okay, so what will happen? Here CH3, CH, basically hemiacetal will form. And here OR and here OH. This is a hemiacetal. Why it is called hemiacetal? So as you can see that here at the same carbon, here it is OR group, which is an ether, right? And here OH group, which is an alcohol group. That's why it is called hemiacetal. Okay. Now, if you remove this H, right? If you remove this H, this hydrogen of OH, what will happen? So if you react again in the next step, if you react this with another ROH group, another alcohol, right, in the presence of HCl, gaseous HCl, what will happen? Here dehydration will occur, right? The water will be loose and you will get acetal. So basically this is acetal. This H will be removed and R dash will form. This is your acetal. Okay. So again, I'm repeating that aldehydes, when it reacts with one equivalent of monohydric alcohols, right? Like in the presence of dry HCl gas, it gives you hemiacetal, right? Which on further reaction with one more molecule of alcohol give acetal. Got it? Okay. So ketones. Now let's talk about the ketones. So ketones react with dihydric alcohols to give cyclic ketones. Let's see how. This is your first example with aldehyde, and second is your, we will talk about ketone. Let's talk ketone. Let's take ketone, right? And when you treat this ketone by ethylene glycol, it is ethylene glycol, CH2, it is attached to another CH2, and here two alcohol groups are there, right? OH groups are attached to both the carbons. This is your ethylene glycol. Okay. Okay. When you pass hydrogen HCl gas, when you pass HCl gas, what will happen? A cyclic ketal ring will be formed, right? From here, you can see from here, water will be loose and here cyclic keton structure this. Here CH2, then again there is a bond. This is a cyclic keton, and there's a loss of water. So that's how the reaction proceeds when you take ketone and when you take aldehyde. Right. So the next reaction is your, it's also okay. Next we will study addition. What happens when you add ammonia or its derivative to carbonyl compound, right? Addition of ammonia and its derivative. Okay. So again, let's take example. Let's take aldehyde or CHO and ammonia. When you give ammonia, I'm writing ammonia. Ammonia is NH3, right? So I'm writing ammonia like this. Why? Because we have to remove water, right? Minus H2, dehydration will occur, and again here also imine will be formed. This is imine. Okay. See, one thing, if in place of hydrogen, if in place of hydrogen, in ammonia I'm talking, right? So there is another, if there is another alkyl group, so what will happen? How the reaction will proceed? Let's see. Suppose that, let's say R H here, double bond O, plus in place of hydrogen, I will take another alkyl group, right? So what will happen? Again, just remove water to the do dehydration, right? So what will you get? Again, do the same thing. Mechanism will be the same. You will get R over here, right? So what is this? This is your Schiff's base. What is this? This is your Schiff's base, okay? And water. Okay. Now we will see the reaction with ammonia derivatives. What will happen when you take ammonia derivatives? So let's suppose we will talk about carbonyl compound. Okay. When you add ammonia, as we learned just now, what will happen? See, it's just a trick. Just remove H2O. What you have to do? You have to do dehydration. Just remove H2O and you will get the product. Okay. So what will happen? NH. This is imine. You will get imine. If so, when you add NH2 and one alkyl group here, you will get the Schiff space. You will get Schiff space. Okay. Again, if you do in the presence of when you react the carbonyl compound with OH hydroxylamine. What is this? This is hydroxylamine, right? So what will you get? So just simple do the dehydration, right? Remove water from it and you will get NOH, right? What is this? This is oxime. This is nothing but oxime. Okay. Okay. What will happen if if your carbonyl compound is treated with NH2NH2? NH2NH2 is what? This is hydrazine, right? So again, do the same thing, do dehydration, and you will get this. This is hydrazone. This is hydrazone. Okay. Now, then tell me what is this? So, this is basically a phenyl hydrazine. So again, what will you get? This carbon, NH, and this hydrogen will be attached to one phenyl group, right? So this is phenyl hydrazone. Okay. Next is your, when you treat this with 2,4 2,4 dinitrophenyl hydrazine. What will happen? First, what is 2,4-DNP hydrazine? Let's see the structure here. See, I'm writing here. This is benzene ring, right? So here 2,4 dinitro. On second and fourth position, nitro group is there, and on first position it is hydrazine, right? That is NH2, right? So this is basically, what is this? 2,4-DNP hydrazine. Hydrazine it is. Got it? So what will happen? So again, water, remove the water from it, and you will get this product type CNH, phenyl group here, right? NO2 here, NO2 here. Okay, so this will be your product. Next is your, when you add carbazine. What is carbazine now? So carbazine is NH2, NH here, CO, NH2, right? So this is carbazine. Again, do the same thing, dehydration, do the dehydration, and you will get semi-carbazole and NH, CO, NH2. So what is it? This is semi-carbazole, carbazole. Okay, so these are the chemical reaction when you add some ammonia derivatives. Next is your oxidation. We will see the oxidation and reduction of aldehydes. Okay, aldehydes and ketones. Oxidation and reduction. So first we will take examples of aldehyde. What will happen? We do oxidation and reduction. So let's take a aldehyde. UHT here, right? First do the reduction in the presence of lithium aluminum hydride, LiAlH4, right? So we are going to do reduction. So on reduction, This LiAlH4 will reduce this carbon aldehyde into alcohol, primary alcohol you will get, like CH3, CH2, OH. Okay, but on oxidation, if you do oxidation in the presence of what? You can use either alcoholic KMnO4, yeah, okay, or you can use the Jones reagent. Jones reagent, what was that? Jones reagent? So the Jones reagent was CrO3, right, in presence of aqueous H2SO4 and acetone. What we are going to get? So on oxidation, the aldehyde will convert into carboxylic acid. Okay, okay, let's see another example. What happened when you take ketone? Okay, let's take ketone. The ketone, right? So first do the reduction using lithium aluminum hydride. So ketone on reduction, it will give you secondary alcohol, right? That's the difference between aldehyde and ketone. On reduction, aldehyde will give you primary alcohol, but on reduction, this ketone will give you secondary alcohol. What will be the product? CH3, here CH, CH3, and here OH. Right, this is 2-propanol, which is secondary alcohol. But on oxidation, okay, so on oxidation, like using concentrated HNO3, so see, basically, the oxidation of ketone is not easy. It's not an easy method. It is only possible in some extreme conditions. Like in extreme condition, it will break, right? The ketone will break and you will get the product. Like in the extreme concentrated HNO3, the ketone will get oxidized and you will get CH3COOH, will get ethanoic acid as well as formic acid. Okay, next reaction is your, again, very important for your board exam, Clemmensen reduction reaction. What is this? Clemmensen reduction process. Okay, so what happened in this? In Clemmensen reduction reaction, acid, it happens in the presence of acid. Like, let's take one example. Let's take carbonyl compound. In the presence of ZnHG, HCl, right? So, in the presence of HCl and ZnHG, so here reduction will happen, right? ZnHG will reduce this. So, what is reduction? Reduction is the removal of oxygen or the addition of hydrogen, right? So, this will reduce this carbonyl compound to here to hydrogen. This oxygen will reduce to hydrogen, right? Or you can write it as CH2 plus water will be removed. Okay. Next is your Wolff-Kishner reaction. Wolff-Kishner reaction. basically you will do reduction process over them, right? So it happens in the basic medium, like just opposite of that remains in reduction process. So you will do this reaction in basic medium, like let's take a carbonyl compound. You will add a strong base, that is KOH, potassium hydroxide, and it happens in the presence of hydrazine, NH2, NH2. This is hydrazine, and in the presence of acetone, right? So here the dehydration will occur, the loss of water will be there, and you will get an alkane. You will get an alkane. Got it? Next is your base catalyzed reaction. We will see base catalyzed reaction. Again, it is very important topic. First one is your aldol condensation. Aldol condensation. It is a base catalyzed reaction. So in aldol condensation, so aldehydes and ketones containing alpha hydrogen. This is the main condition, right? The aldehydes and ketones which are having alpha hydrogen atom, they only undergoes aldol condensation, right? And this happens in the presence of dilute alkali as a catalyst, which forms a beta hydroxy acid aldehyde, right? A beta hydroxy aldehyde, you can say aldol, or beta hydroxy ketone, like ketol. Let's see the reaction. Okay, so let's take 2 moles of CH3 COH. I'm doing it with the aldehyde, right? You can also take ketone also. You can take ketone also, right? So in the presence of dilute NaOH, what will happen? What will happen? So let's see. Let's see the proper mechanism. You will get aldol, right? When you react uh, with the dilute NaOH, first see here, is the alpha hydrogen is present in this compound? Yes, there are 3 alpha hydrogen, right? So the reaction will proceed. First, you have to check that. If there is no alpha hydrogen, then the reaction will not proceed. Right? Then the aldol condensation will not happen. And again, here 2 moles of aldehyde or ketone is needed. Okay, and you will get first you will get aldol. What is aldol? Today we will see the proper mechanism. What will happen? And pH CH2, COH. Okay, so what is this? This is aldol. Aldol is beta. See, at beta position, there is a hydroxyl group. That is, this is your alpha position, and this is your beta position. So what does its name? Beta hydroxy aldehyde. Got it? Which is known as aldol. Let's see the mechanism. Okay. See, CHO. I'm writing CH2 and one hydrogen like this. Right. When you give NaOH, OH minus ion will be there, right? This OH minus will abstract this hydrogen, right? And this bond will goes, this electron will goes there. Got it? So what will happen? This carbon will achieve negative sign and CHO, right? And here water will lose. Again, another mole of aldehyde, that is CH3, COH, right? So if in this bond, CO bond, the carbon is positive charge, right? And the oxygen is negatively charged due to electronegativity, high electronegativity. So this negative charge will attack this carbon, right? So from here you will get C here O minus, CHO, sorry, CHO, and here CH2, here C, here O minus. Okay, that's what you get. Hope you understand it. Then H plus, in the presence of H plus, this H will goes to that oxygen OH, forming beta hydroxyaldehyde. Got it? So this is your aldol. Beta, at beta position, there is a hydroxyl group, so its name is beta hydroxyaldehyde, right? So again, if you give some heat and if you provide heat, so from here, OH, this OH, this H will liberate out as water, right? So here, from here, dehydration will occur, and you will get an alkene, this CH3, okay? CH3, here CH, and here double bond. It will form double bond. CH, CH. Got it? Right. So the one hydrogen from there, and here from one OH from there. This will liberate it as H2. Dehydration will occur, and you will get the bute-2-enol. What is this? Bute-2-enol. That is aldol condensation product. Okay. I'm giving you a question, right? Do it by using ketone group, right? Same mechanism. From same mechanism, it will proceed and you will get ketal, ketal group, right? Beta hydroxy ketone. So you have to tell me what will be the product. Do it yourself. This question very easy. Same mechanism. Okay. So the next is your Cannizzaro reaction. Cannizzaro reaction. So what is Cannizzaro reaction? So basically in this, aldehydes that do not have alpha hydrogen, just opposite of in aldol condensation, there is a need of alpha hydrogen, right? But in Cannizzaro reaction, uh, there is no need of alpha hydrogen, right? Aldehydes that do not have alpha hydrogen that undergo self-oxidation and reduction, right? On treatment with concentrated alkali, which is called also it is also called a disproportionation reaction. Let's see how it happens. No need of alpha hydrogen. There is no need, right? Because it undergoes self-oxidation and reduction and on treatment with concentrated alkali, okay, also called disproportionation reaction. Like, let's say the reaction, if you take 2 moles of formaldehyde, check if there is an alpha hydrogen. No, there is no alpha hydrogen, right? So if we do oxidation, we will get carboxylic acid. But see here, NaOH is there, right? So we are going to use the concentrated NaOH, concentrated NaOH. So on reduction, if you reduce this, let's reduce this reduction. On reduction, what will be the process? You can use any reducing agent, and what will be the product? So this formaldehyde, this aldehyde will reduce to alcohol, right? And what if what if we will done oxidation? Hmm? On oxidation, the aldehyde will convert it convert into carboxylic acid. Okay, carboxylic acid. But see here, we are using sodium hydroxide. So the metal is there, right? So it will form salt. Okay, so what will be the product? HCOO. Okay, this is the Cannizzaro reaction. Let's take another example. Okay, uh, so take benzaldehyde. You can take benzaldehyde. Why? Because it also has no alpha hydrogen. Let's take 2 moles of benzaldehyde. Okay, so this is benzaldehyde, and we are taking 2 moles and treating it with concentrated sodium hydroxide in the presence of heat. What will you get? Again, do the same thing. Do the same thing. First, you have to do oxidation, then reduction, right? Do the oxidation. What will you get? You will get the salt, COONA. Right. On oxidation, the carbon aldehyde will convert into carboxylic acid, but here sodium is there, so it will form the salt, sodium benzoate. This is sodium benzoate plus and another product will be there oxidizing, uh, which which is the result of oxidation, right? So on oxidation, benzaldehyde will convert into what? Benzyl alcohol, right? Okay. So these are very, very important for your exam point of view. Cannizzaro reaction, aldol condensation, right? Wolff-Kishner reduction, Clemmensen reduction. The examiner can be asked direct, right? So write the mechanism of aldol condensation, write the mechanism of Clemmensen reduction. So, hope you got my point.